How you doing, everybody? Randy Richard in the shop, and today I'm going to do a job that I do about once a year for a friend, and he has a custom automotive business, and he's in partners with another business that he has that he's with. I'll put their address or something there if you're interested in stuff that they do in the description. And Max Plowman is his name. And Max is a good friend, and so he asked me to make these bushings for him a few years ago, and so I make a small batch of them every year for him in some of his custom work he does. Mostly prototyping for suspension systems and stuff. So therefore these bushings are for Heim joints or they're spacers. There's a quick drawing if you're kind of wondering what I'm doing. There's no real secret about them. You can buy them, but evidently I'd probably make them cheaper than you can buy them for, it sounds like. And I haven't really looked into it. And then CSC shops want to make 100 of them, and he doesn't want 100 of them. So, anyway, I'm going to make them. I make them for him, which is kind of fun. So, I'm going to take off this chuck, put it in a 1-inch collet, so I can hold the stock. It's a 1-inch 304 stainless, and we'll get started on them. So this chuck is fairly heavy. Let's see here. I'll stick this piece of maple in here so I can handle the chuck a little easier. This is a L00 mount. This support is a little on the high side. I made it for my 4-jaw, I think it was, and they were just a little bit different. These chucks are just a little bit different in diameter, so for this chuck it's a little on the high side. That's okay. It's hardly anything, so just makes it so you can't quite turn it by hand and thread here. It's heavy. That's a 10-inch 6-jaw buck chuck, if you're interested. Been pretty busy with a couple projects and trying to keep up with the mess. It's tapered and a key and a nut. This will go on here. Not yet though. So this is the back side of the headstock. This is the spindle here, and there's a double key on this spindle and this groove. The collet closer, it's a really nice collet closer actually. It's all ball bearings and everything. It's pretty nice. Anyway, so this is going to slip in there like so. And then we line up the keyways lined up here. Put a little WD in there. That'll make a difference. There we go. Now I have you zoomed in here. This is where you attach it to the spindle, and there's a groove I showed you on the spindle. This is kind of interesting. There's 3 little shoes that close in to that groove, and it makes it pretty much a precise fixed placement on that shaft. Keyway is for turning, obviously, but the axial movement is locked in. So this screw here pushes the key into the groove. This screw pulls the key out of the groove, so when you want to take it off. So right now these are tight, holding the keyway back so you can get it off. Now, so you have to loosen this. It's kind of interesting. You loosen that, and then you can screw this keyway down. And so you keep loosening until you know that the keyway is now seated, and then I just kind of snug it so it doesn't fall out. Kind of interesting. Kind of like, I don't know. I've never seen this method on anything else really, so it's kind of different, right? So you loosen that bottom one, turn the top one until you know it's seated, and then tighten this one just a little bit, just hardly anything. That's how it attaches. Pretty simple. Then over here you have your actuation arm, the pivot for it, and that just slips into the arm. And then I just put that on hand tight. That's all it needs to be. Anyway, there you go. And then this is the adjustment for the tension on the collet. This is a 5C collet closer. This thing works awesome. It's great to use on here. And back over here at the nose. Now, I made a special wrench for this that fits on here. Right there, right? And this has a ring in the middle. So this screws onto the closer tube this way up to the ring, and then the collet screws in on this end. So you got to. Now this doesn't fit through the spindle bore. That's why you have to do this in the right order. So you got to put the closer in, then you put this in. And that's just basically hand tight. So that's all it is. You don't even need to turn it all the way, even if you don't want to. But I just barely, just hand tight kind of thing. Then this goes on. Now this is all keyed. The spindle part nose here, and then this will go in. This is the adapter. This is a Morris taper number 5 spindle, and then this adapter goes in, and the 5C will seat in this. And we just a little tap, cinch it down. Like I said, then this. Now this, I have an alignment mark on it, and then there's a mark. This only goes on one way on the key, and then there's a mark on here, and we'll put these lined up because this was broken or cracked, I should say, when I got the lathe. What I did is I put it back together. I pressed it back together a bit, and I re-brazed it in here, and then re-machined that out, and and then I reground the internals of this for concentricity. Now I did a video on that. It was quite a while ago, but I did a video on doing all that. So if you're interested, you can look that up. Okay, there's my mark. And we just kind of line that up. Give a little tap. Now to get this out, when you undo this nut, it will pull that adapter out. Then we'll put this collet in. Now for these, now I don't have a pin in this. I took that out because it was just causing way too many issues. Anyway, so I just put this in here, and this allows me actually, if I need to adjust it a little bit, I can. But for these parts, it's not an issue. The OD tolerance is not fit to anything, so it can be 15, 20 thousandths. It's not a big deal. But anyway, this, you hold it in and then screw the back there, that adjuster, to screw the collet into the tube. There you go. See how that works? Probably have it in there too much already. And our stock can go in. Now these things are only about 1.25 inches long, the pieces, the bushing. So I think I usually pull it out. I think I usually do about 2 inches, but we'll do, I can probably get in there 1.25 inches. Yeah, probably do that 1.75 inches or so. Then get your tension set. Okay, we're set. We're ready to machine. So these are all done to this point here, and we have to do a second op on the end here just to clean up, run the drill through to clean all this off, face it, a little file chamfer here, and then after I take it out, I chamfer the inside the bore here on the end with a drill and chamfer tool. So yeah, and the critical dimension, the most critical dimension is, of course, a couple dimensions. This here dimension, so it fits real nice in the Heim joint, and then from the face here to the end here, so they're all consistent. This end can be trimmed to fit when you're fitting the Heim joint in the bracket or wherever you're mounting it. But I make them all so that they're all within about 10 thousandths. It's a tolerance. But it's kind of critical. This is probably the most critical, the bore here, so it fits real nice. And this is just a drilled hole. So this goes pretty fast. And I've already set where the position is here, so this is very consistent. I lock the carriage, and I just file this edge. And it comes out pretty nice. And then I just chamfer that. Now, quick chamfer on the inside here. This goes pretty simple. That's about it. And boom. For the most part, it's really kind of soft. A little soft. That's soft. It does sometimes. I'll put these in here. Get them opened up. Then I'll press them and we'll convert them. Here we go. Into the cleaner and we're done. And thanks you guys for watching. And please support the channel. Please join the membership. It's really cheap. And join at the drawing level and you can get any drawings I've made, especially in a video. You can request and I'll send them to you, 3D or a 3D file if you want to make the item on a CNC machine, whatever you want, and I'll send those off to you. Other than that, I don't send off drawings just to everybody anymore. Anyway, thank you again, and we'll catch you in the next one.